So now in this question is asking standard enthalpy of formation of acetone is minus 250 kilojoule per mole. What is the standard enthalpy of the combustion in kilojoule per mole for acetone? The enthalpy of formation of CO2 and water are given to us. 4 options are given to us. Let's go to the solution. Now, to solve this question, first we have to write down the chemical equation. So, for the oxidation of acetone, that is C3H6O plus 4O2, that gives thrice CO2 plus thrice H2O, right. Now, we have to apply the formula. Enthalpy of reaction, this particular reaction, you can say the enthalpy of the combustion of acetone, right. So, that will be enthalpy of formation of the product minus enthalpy of the formation of reactant. So, if we write enthalpy of formation of the products are carbon dioxide and water. Therefore, it will be 3 multiplied by, now the enthalpy of formation of CO2 is given to us. So, it is minus 394 plus 3 multiplied by enthalpy of formation of water, that is also given to us, that is minus 286 and minus enthalpy of formation of the reactants. So, one of the reactant is the acetone and enthalpy of formation of acetone is given to us, that is minus 250 kilojoule per mole. So, we will write here minus 250 kilojoule per mole minus enthalpy of formation of oxygen. Now, oxygen is an element, that is why enthalpy of formation, the standard enthalpy of formation of the oxygen will be 0, right. So, you can write it is 4 into 0 and at the end we will get the answer 1790 kilojoule per mole of acetone, right. So, let us check the options. Now, second will be the correct answer, right. Let us move on to the next question. Now, in this question is asking 8.575 grams of KClO3 decomposes on heating partially according to the reaction number 1 and the rest decomposes according to the reaction number 2. Two reactions are given to us. First is twice KClO3 on heating gives twice KCl plus thrice A2, and second is 4 KClO3 on heating gives us KCl and thrice KClO4, right. Now, the volume of oxygen gas evolved in the reaction 1 measures 1.008 liters. At STP, what is the percentage of KCl in the residue? Atomic mass of chlorine is given to us, that is 35.5, and potassium is given to us, that is 39. 4 options are given to us. Here are the 4 options and we have to find the correct option, right. So, let us solve it. Now, first we have to find out the number of moles of KClO3. So, the total number of moles of KClO3, that will be equal to its given weight. The given weight is 8.575 grams. So, 8.575 divided by 122.5. This is the molar mass of KClO3, right. And when we will solve it, we will get 0.07 mole, right? So these are the total number of moles of KClO3. Let's talk about oxygen. The number of moles of oxygen, that will be equal to the volume liberated, that is 1.008 divided by 22.4 liter, and that will be equal to 0.045 mole. So 0.07 is the total number of moles of KClO3 and 0.05 is the mole of oxygen, right? Now weight of oxygen, that will be the total number of moles of oxygen, that is 0.045 multiplied by 32, and that will be equal to 1.44 grams. Now this will escape out, right? Now for equation number 1, means we are talking about twice KClO3 gives twice KCl plus thrice O2, means when we will get 3 moles of oxygen, we require 2 moles of KClO3, but in this case we are getting 0.045 moles of oxygen, right? So for the first equation we can say that 3 moles of O2 corresponds to 2 moles of KClO3, right? And 0.045 mole of oxygen, that will give us 2 by 3 multiplied by 0.045 moles of KClO3, right? And this will be equal to 0.03 moles of KClO3. Now this is for the equation number 1, right? Now the total number of moles of KClO3 is 0.07. Therefore we can say that in equation number 2, the amount of KClO3 or the moles of KClO3 which are used, that will be KClO3 which is used, that will be 0.07 moles minus 0.03 moles, that is equal to 0.04 moles, right? So if we talk about KCl now, we have 0.03 mole of KClO3. So definitely we will get 0.03 moles of KCl. So this will also be 0.03 moles, right? And in the second reaction, 4 moles of KClO3 is giving 1 mole of KCl. We have 0.04 mole of KClO3 for the second equation. Therefore this 0.04 mole of KClO3, it will give us 0.01 mole of KCl. Now we have to add this. So when we will add it, the total number of moles of KCl, that is equal to, first we are getting 0.03 from the first equation, and 0.01 from the second equation. Therefore, 0.03 plus 0.01, that is equal to 0.04 moles, right? Now let us find the weight of KCl. So, the weight of KCl will be equal to 0.04, its number of moles, multiply by 74.5, which is the molar mass of KCl, and that will be equal to 2.98 grams. Now we got the weight of KCl, right? Now we have to find out the weight of residue. So when we will find the weight of residue, weight of residue, that is 8.5, the value is, the total weight was 8.575. So it is 8.575, this is the total mass, minus the mass of oxygen escaped. So it is 1.4, here it is 1.44 grams, that is the weight of oxygen that has been escaped. So 1.44, and that will give us 7.135 grams, right? So this is the weight of residue, and we have to find out the percentage of KCl in this residue. So the percentage of KCl, that will be equal to 2.98 divided by 7.135 multiplied by 100 is equal to 41.77%, right? So let's find out the correct option. Here it is, 41.77, and our correct answer is option number 4, right? Let's move on to the next question. Now, in this question is asking, if the wavelength of the photon is 2.2 into 10 to the power minus 11 meters and Planck's constant is given to us, that is 6.6 into 10 to the power minus 34 joules second, then the momentum of the photon is, 4 options are given to us. So we can find out the momentum of the photon by, let us solve it. So we can find by lambda is equal to h upon p, right? And the momentum p, that will be equal to the Planck's constant divided by the wavelength. Now Planck's constant is 6.6 into 10 to the power minus 34 divided by wavelength is given to us, that is equal to 2.2 into 10 to the power minus 11 meters. So it will be 2.2 into 10 to the power minus 11 meters, and the answer will be 3 into 10 to the power minus 23 kg meter per second, and our correct option is the option number 1. So the answer is answer number 1, right? Let's move on to the next question.